Okay, in this video we're going to talk about the 30, 60, 90 special right triangle, okay? In a 30, 60, 90 triangle, the length of the hypotenuse is always twice the length of the smaller leg, which is across from the 30-degree angle. And the length of the longer leg is always across, which is across from the 60-degree angle, is always going to be radical 3 times bigger than the smaller leg. So just thinking about what's been said here, everything's kind of based on this smaller leg here, all right? So the smaller leg is going to be opposite 30 degrees because that's the smallest angle. The other leg is going to be opposite 60 degrees, and then the longest side, or the hypotenuse, is going to be opposite the 90-degree angle, okay? So moral of this story is, if you are not given the smaller leg, you're going to have to find that first, okay? So let's look down here at example 4. In this case, we're given the side opposite the 60-degree angle, so it's the larger of the two legs, okay? So because we have the longer of the two legs, we need to find the smaller leg first. We're going to have to divide by radical 3 to do that, okay? Anytime you divide by that radical expression, or most times you divide by that radical expression, you're going to need to rationalize, okay? And we've gone over that previously. Once you have the smaller leg, then you'll be able to double that, okay? Multiply that by 2 to find f here, which is the hypotenuse, okay? So first thing is, d here is going to be the longer leg divided by this radical 3. Okay, that's the relationship. Because we have a radical expression in the denominator, we need to rationalize. Okay, so that's going to give me 5 times radical 3 in the numerator over radical 3 times radical 3, which is radical 9, or 3. So the answer here for D is going to be 5 radical 3 over 3. Okay, to find F, we're going to double that. Okay, we're going to multiply that by 2. Okay, so 5 radical 3 times 2 is 10 radical 3 over 3, okay? These are exact answers. You could convert those to decimals if you want to approximate that length, okay? But we want to stick with exact answers when we can, all right? So again, to find D, we divided by radical 3. And to find F, we found this D value first and then doubled it, okay? If you try to relate the longer leg and the hypotenuse, the math gets a little bit tougher. So that's why we always want to find the smaller leg first, okay? Let's look at example 5, okay? We're given the hypotenuse first, okay? I want to use that to evaluate the smaller leg next, okay? So the smaller leg is going to be x because it's opposite the smallest angle, 30 degrees, okay? Now remember, the relationship is the hypotenuse is twice as big as the smaller leg when we're dealing with a 30, 60, 90 triangle. So to find x, I'm going to divide by 2. Okay, I'm going to divide the hypotenuse by 2. So 8 divided by 2 is 4. Okay, now that I know 4, that's going to allow me to find the longer of the two legs. Remember, the relationship between the smaller leg and the larger leg, well, the larger leg is radical 3 times bigger. So I'm going to multiply by radical 3, and that gives me 4 radical 3. Okay, now let's do a word problem here. We've got a moose warning sign, which is an equilateral triangle. Well, that means all of these angles are 60 degrees, okay? Each side is 1 meter long. That means each of these sides is 1 meter. And we want to find the area of that sign, okay? So to find the area, remember, we need to find the height, okay? The area of a triangle is A equals 1/2 times the base of the triangle, which is 1, times the height of the triangle, which I don't know yet, okay? So when we divide an equilateral triangle into 2, so when we draw this height here, I've got a 30, 60, 90 triangle here and a 30, 60, 90 triangle here, okay? So because this is broken into half here, each of these parts is going to be 0.5, okay? They're going to be equal parts, so each of these is 0.5, and they're going to be the side opposite 30. This angle is 30, this angle is 30, okay? So in order to find the height, I'm going to multiply that. This is the smaller leg. I'm going to multiply that by radical 3. Okay? So I'm going to multiply 0.5 times radical 3 to get this height, which is approximately 0.866. And in this case, we're talking about meters. All right? So to find the area, again, the formula is 1/2 times the base times the height. The base of this equilateral triangle is 1. Okay? So we've got the 1/2 times the base times what we just calculated for the height, okay? We want to multiply these 3 values together. So we get the area of this warning sign here for the moose to be approximately 0.433 meters squared, okay? And that's how you use the 30, 60, 90 triangle and those concepts to solve real world problems, okay?